Welcome again, friends. Welcome again in another video lecture from Microbiology with Shagnik. In this video, we are going to talk about dot ELISA. Now, you guys may wondering that why I have made a new video regarding dot ELISA, because in our previous upload, I have made a major mistake. I am sorry for that. That I have forgotten to add substrate. That is our TMB-H2O2, and I have completed the video. So how here this spot, or we can say blue or gray spot formed, there was no clue about that. So I feel sorry for that, and I have made now a updated video for dot ELISA, and I will promise that this video will be helpful to you, and it will cover everything that you need to know regarding dot ELISA. Okay, so without any wasting time, let's get started. So before going to talk about dot ELISA, you need to clear the concept of sandwich ELISA. Okay, so why we need to develop sandwich ELISA from direct ELISA? I have made a video in this. If you want to know, then please go to my YouTube channel and search for this, and you will find a video regarding the basic ELISA. Okay, so let's start. So for doing dot ELISA, you need to have a test tube where you will add 1 ml of 1x assay buffer. Now, one thing is that 1x assay buffer will not be provided to you. You will be provided with 10x assay buffer, and you need to convert it into 1x assay buffer. Then how you can convert it? Okay, this is very simple. You need to know this simple calculation. One, for you need to prepare 1x assay buffer, and you have 10x assay buffer, and you want to prepare 1 ml. Okay, that means equation will be something like that, and you will have 0.1. okay, that means 0.1 ml assay buffer you have to mix with 0.9 ml distilled water. Then you will have your 1 ml of 1x assay buffer. Okay, I hope it is clear. Then you have to mix it with 50 microliter of serum sample. Then you will mix it thoroughly. After that, let's come here. In normal ELISA, we will perform the whole technique in case of a microtiter plate. I hope it is clear to you. And in case of dot ELISA, which is in general a kit based process, we use a ELISA strip. Okay, and in this ELISA strip there are 3 specific zones. One is negative control zone, where you have your inner protein. That means there is nothing, the this zone do not contain any immune component, you can say. Okay, and the middle portion is your test sample, where you have your immobilized antibody. Okay, but not bound with antigen. Okay, and third one is your positive control zone. Okay, that is in that zone you have immobilized antibody along with antigen specific to that antibody. Okay, then you can easily interpret that what will be your result after doing the whole process. What if the process is negative? That means antigen is not present in your serum sample. Okay, then you will have a dot only there, because it is your positive control, and here antigen is already present. So when you add the secondary antibody, it will generate color. But if there is no antigen in serum, then when you will going to add the secondary antibody will not bound with anything, because there is no antigen to bound with, right? So in that case, negative control will have only one spot, and positive control will have two spot. Okay, that means no matter what the result is, in positive control zone you will always have a spot. Now you have to insert this strip in the tube, where we have prepared a mixture of 1 ml of 1x assay buffer with 50 microliter of serum samples. Okay, and you need to allow the reaction to occur for 20 minutes. Okay, after that you have to wash the strip in 1 ml of 1x assay buffer for 5 minutes, and each time you will replace the buffer. Okay, so you will have adequate washing. After wash strip, after you have your wash strip, you have to prepare another tube where you have 1 ml of 1x assay buffer and 10 microliter of HRP antibody conjugate. Okay, then you will dip the ELISA strip in that tube and allow the reaction to occur for 20 minutes. Okay, after doing this, you need to again apply the washing step that is similar to this step. What you need to do, you need to take a test tube where you have your 1 ml 1x assay buffer, and you will rinse, or you can say you will dip the in the ELISA strip there and allow for washing 5 minutes. Then you will replace the buffer, and again you will take a fresh test tube where you have 1 ml 1x assay buffer, and you will again dip the wash strip, previously wash strip hit there, and allow for washing for 5 minutes. Then you will again repeat the process once. Total you have to repeat the process 3 times. Okay, after that you have again your wash strip, and you will have to now prepare. This was the step that I have missed in our previous video, and that is the reason why I need to update this. Okay, so second again sorry for that. So again you have to take a fresh test tube where you will add 0.1 ml of the 10 x TMB H2O2, and you will add again 0.9 ml of distilled water. Then we have a total 1 ml of solution in this test tube where we have 0.9 ml of distilled water and 0.1 ml of 10x TMB H2O2. Then we will dip our strip again here and allow the reaction to occur for 20 minutes. Then we will look for our blue or gray spot Okay, that is the reason why if that we will have if our result is positive. We will going to talk about this. Then we will ultimately rinse our strip to stop the reaction. Okay, now let's talk about observation. If suppose our result is positive, that means in our 50 microliter serum sample we have our antigen of interest, right? Then in test zone, which was only consist of immobilized antibody, it will interact with your antigen of interest. Then when you will add your enzyme linked secondary antibody and add TMB H2O2, it will give color product. Okay, and as it is a precipitation reaction, then you will have a spot like this, and as it is your positive result, then you will observe 2 spot. Okay, and in case of negative result, as it is obvious that it is there is no antigen present, so when we add our secondary antibody, that is 10 microliter of antibody HRP conjugate, they are unable to bind with our test zone's immobilized antibody, and that is the reason why in negative results we have our ELISA strip consisting of only one spot. Okay, now the question is why blue or gray spot is formed. Okay, so you need to know one thing, that this is the substrate for HRP. So what this HRP is? HRP is simply horseradish peroxidase. Okay, this horseradish peroxidase will react with this substrate. The substrate is mainly among TMB H2O2, the main substrate is H2O2. This H2O2 will react with HRP and release oxygen from H2O2, and this oxygen again going to react with TMB and produce TMB oxide. Okay, and this TMB oxide will gives blue color. Let me repeat. This I have said that this horseradish peroxidase is an enzyme that have the ability to interact with TMB H2O2 substrate. Okay, and then when we will react with the H2O2, this H2 this HRP will release oxygen from this H2O2, and this oxygen will again going to react with TMB, and you will have tetramethyl benzidine oxide, and that will blue in color. Okay, so that is the reason why in case of positive result we have 2 blue or gray spot, and in case of negative result we have 1 blue or gray spot. Okay, and this is the reaction if you want to make notes. Okay, so HRP reacting with H2O2 releases the free oxygen, which on further reaction with TMB gives you tetramethyl benzene oxide, okay, and that is blue in color. So that is overall about dot ELISA. I hope this time there is no mistakes made by me. Please apologize me for please forgive me for my previous mistake, and I hope that this video will be helpful to you, and if it is, please like the video, share with your friends and subscribe my channel. Thank you.